the obvious theorem in the previous class. Now we shall continue the discussion. So the basic concept, you can see that this is basically related to polar form of complex number, polar form of complex number, and there are certain operations which this particular theorem allows us to do so. That's why we are reading this. So this is the De Moivre's theorem. Cos theta plus iota sin theta raised to power n. The power gets divided and gets multiplied with the argument. Now, some things to note here is that cos theta plus iota sin theta. Now here, note one thing that the iota is with the sin theta, okay? And both of the angles are same. And okay, so this is a thing to note if there is a written something like this. Now we cannot write and apply the same result here. No. Why? Because this expression is changed now. Clear? Any doubts, anyone? Any doubts?
No, sir.
Okay. And also both of the angles are same. Let's go ahead and discuss more properties of this we have already covered. If something is getting multiplied, some expressions of this, so they can be written in a single expression when the angles will get added and also the angle sine term. There was also one question that we had to discuss, but the class got over because of time. So given arithmetic mean of A, B, C, D, E is 5. So what is the arithmetic means formula? Basically the sum of all observations upon the number of observations. How many observations are there? How many elements are there? 5, right? And the answer is also given as 5. Okay, so the sum A plus B plus E plus D plus E is 25. Clear. So we have to find out this. As we know from the property, cos A plus iota sin A, both of the angles are same. Iota is with the sine. So it is the same with every other term. We can write it as cos A plus B plus C plus D plus E plus iota sine of A plus B plus C plus D plus E. So this can be written like this. Okay. Now we know the sum. This is cos of 25 plus iota of sine of 25. Clear? This is our answer. Clear? Any doubts, anyone?
No doubts, sir.
Let's move ahead now and discuss more properties. So this we have already discussed. Now, if z is equals to if z is a complex number, r is the magnitude multiplied by cos theta plus iota sin theta, and n is a positive integer. Okay, positive integers are natural numbers 1, 2, 3, 4, 5, 4, 6, as I said, where k is 0, 1, 2, 3 to n minus 1. Okay, where is k? So 2 into k into pi, where k is also an integer. So if this is like 2 pi, 2 pi almost means 0, right? 2 pi is what? 360 degrees, full circle, equivalent to 0. Clear? Any doubts?
No, sir.
Okay, so what is there given that there is a complex number. If we change its power to 1 by n, so what will happen? Simply the angles will get multiplied by 1 by n. So if it is getting multiplied by 1 by n, n is going to be written in the denominator. That's simply written. Okay. 2k pi is written for convenience. Okay. Where k can also become 0. And if it is 1, then also it's like 2 pi. Then it is also similar to 0. Because after a full angle, the angle becomes 360 or 0. Next property. And is this property clear? Any
Yes.
doubts? Let's take an example. 1 plus 1 iota. So what's its magnitude? Square root of 2, right? Square root of 1 plus 1 square. And what is its argument? It's actually 45 degrees. Clear? This lies in first quadrant, tan inverse of 1 by 1. That is 45 degree is 1. So that's why 45 degree angle. Okay. And it is also in the first quadrant. That's why alpha is going to be theta, which is our argument. Any doubts, anyone? So we can write this in this format. Cos of 45 degrees iota sine of 45 degrees. Clear?
Yes, sir.
Now, let's say we had to find out z raised to power 1 by 3. It's like we are finding out the cube root of complex number. So what we'll simply do, we are taking 1 by 3 power. So this becomes cube root and square root of 2. 1 by 2 into 1 by 3, 1 by 6. Cos of 45 pi by 4 plus iota sine pi by 4 raised to power 1 by 3. Now using De Moivre's theorem, we can write cos pi by 4 divided into 1 by 3 multiplied by 1 by 3 plus iota sine pi by 4 multiplied to 1 by 3. So this becomes 2 raised to power 1 by 6 to cos of pi by 12 plus iota sine pi by 12. So this is our cube root of v. Now what is pi by 12? If we convert this in degrees, this is 15 degree, right? So what is cos 15? Can anyone tell me? We will learn in trigonometry chapter. So this is cos 15, this is sine 15. Now, if we have to find out the cube root of the complex number, now what I'm teaching you is the application of De Moivre's theorem. So cos 15 is root 3 plus 1 upon 2 root 2 plus iota of sine 15 is root 3 minus 1 divided by 2 root 2. 2 root 2 is the 2 raised to power 1 by 6, okay? And 2 root 2 is the LCM. So root 3 plus 1 plus iota into root 3 minus of 1. Now, this is basically what? 2 into root 2 means 2 into root 2 is 2 raised to power half. Its power is 1. So the both of the power will be added, right? It will become 3 by 2. Why added? If there are two exponents with same base and different powers, so their power will be get added. So 1 plus 1 by 2 will become 3 by 2. So this can be rewritten as 3 by 2. 2 raised to power 3 by 2. Now 2 raised to power 1 by 6 subtracted by 3 by 2 into whatever is there. Okay, this is their answer. No 2. This is their answer. We can also solve this 1 by 6 minus 3 by 2. 6 LCM, 1. 3 LCM, so that becomes minus 8 by 6, which is minus 4 by 3. Okay, so this can be rewritten as this is our final answer. We have found out the cube root of the complex number. So see how easily using De Moivre's theorem, we are able to find out any exponent to the any complex number, right? First, what we did, we find out the magnitude and the amplitude, and then we find it out its polar form, and using the De Moivre's theorem, we find it out Z. Clear?
Yes, sir.
Yeah. So this point is also clear. Yes. Now this is one point to add, that even if there is a negative sign in between cos theta and iota sin theta, then also this De Moivre's theorem will work. Earlier there was a positive sign. This time there is a negative sign. Okay. Okay, and also we have discussed this property earlier. It's the same. Minus 1 will get multiplied to theta. Cos of minus theta is cos theta. That's why it is the same. And sine of minus theta is minus sine theta. That's why it is written like that. Clear? Any doubts?
Now, sir.
Now, this is one point to note, that if iota is with cos theta, so that we cannot directly apply De Moivre's theorem. First, what we need to do in this case is that we will change sine into cos by doing this operation, and we will change cos theta into sine theta. As we know, cos of pi by 2 minus theta is what? Sine theta. So similarly, sine theta can be written as cos of pi by 2 minus theta. So the same we have done so. So, and then we'll go ahead, we'll apply the De Moivre's theorem now. Clear?
Yes, sir.
Great, great. Let me save the file first. Next property, if there are different angles, the property will not work. Let's move ahead and discuss the next topic, which is finding the square root of a complex number. And also, if we are able to find out the polar form of any complex number, then it will be very convenient for us to find out the square root. But it will happen sometimes that you are not able to find out the exact amplitude, because for finding out amplitude, what we need to do is that we have to take an inverse trigonometric function, which is tan inverse function. And now we don't know all the sorry we don't know all the inverse values, or we don't know all the trigonometric values for tan function, right? That's why we'll not be able to find out amplitude each and every time. So that's why we are going to learn a new method for this. So let us say if we have to find out if there is a complex number x plus iota y, where x and y are real numbers, as we know, and we have to find out the square root of the same. So the square root of a complex number will also be a complex number. So let's consider that a complex number to be a plus iota b. Okay. So in this case, if we consider this equation, okay. So let's take square on both sides. So after squaring both sides, we can write the square root will get cancelled, and the square root will be added here. So let's solve the right hand side. A square plus iota b square. So iota b square, so iota square will make it this negative plus 2ab into iota. If we compare the left hand side and the right hand side, they are both complex numbers. And as we know, if two complex numbers are equal, their real part and imaginary part will be equal. So similarly, writing x is equals to a square minus b square, and y is equals to 2ab. So clear? Any doubts, anyone?
No, sir.
Now our objective is to find a and b, because that is what we need to find out. So how can we find out a and b from these two equations? This is a this equation's degree is 2. Okay. So let's do one thing, and as we have these two terms like 2ab and ab, so we'll try to make some algebraic identity using the same. So if we take this equation and this equation and add both of them, after squaring. So let's say x square plus y square, left hand side square, and a square minus b square, its square plus 2ab square. Let's see what it becomes. Now a square will become a raised to power 4 plus b raised to power 4 minus of 2a square b square plus this is what 4a square b square and let's solve it further. This becomes a raised to power 4 plus b raised to power 4 plus 4 minus 2 becomes plus 2. Okay, so is this a equation for something? Is this an identity for something? What is a square plus b square? And if we say a is a square here and b is b square here, so there is a identity which is making up. Getting it?
Yeah, sir.
Let me write it different. Now just tell me, simple. What is the expansion of this? Anyone? Unmute yourself and tell me what is a square plus b square raised to power 2? Simply, you don't have to do anything else. Like there is a algebraic identity we have studied.
A4, it's a to the power 4 plus
Yes.
b to the power 4
So a to the power 4 plus b to the power 4 plus
plus
2.
2a square b square.
So this is the algebraic identity of this. Clear?
Yes, sir.
Yes. So let's utilize our observation now. Adamant. X square plus y square becomes a square plus b square whole square. Okay, clear. So let's bring the whole square to the left hand side because now what is like let me write it first then explain. So this becomes a square plus b square. Now if you observe equation number first and third, so we have a square plus b square and a square minus b square. So if we add equation 1 and 3, then on the right hand side b square will cancel b square and only one variable will be left. So that means that we will be able to find out the value of a, right? Congrats, we have solved it. So after adding, on adding 1 and 3, on adding 1 on 3, so x plus, this is what? Square root of x square plus y square is what? What is the modulus of z? What is the magnitude of complex number? Right? It is so, right?
Yes, sir.
Yeah, so this can be rewritten as modulus of z. So x plus modulus of z is equals to a square plus b square. So a square minus b square plus a square plus b square cancels. That becomes 2a square. So x plus modulus of z, x plus modulus of z is equals to 2a square. Now x plus modulus of g is equals to a square divided by 2. I think there is a problem with the solution. I'm checking it again. X plus this, okay. Okay, no problem, no problem. So a square is this. Now if we take square root of anything, so what becomes a, if we write x square is equals to 4. So x is equals to what? Anyone? We take square root on both sides, so this will become
2
x. This will become what?
root 4, which is equal to 2
2 plus minus 2.
plus or minus 2.
Yes, plus or minus 2. So similarly, if we take its square root, so its plus and minus value will be the. Now let's solve for the. Let's solve for. Let's solve for b. How we will solve? We'll simply do one thing is that we will subtract equation number 3 from equation number 1. No, we will subtract equation number 1 from 3. So modulus of z minus of x will become a square plus b square minus, so a square plus b square minus of a square minus b square. So minus of a square minus 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 b square. Modulus of z minus x. So a square plus b square minus of a square minus minus plus b square. A square cancels a square. This becomes 2b square on the right hand side. Okay, this becomes 2b square. Now b can be written as modulus of z minus of x divided by 2 and then square root. Any doubts, anyone?
No, sir.
So from the given as assumption, we have taken modulus of z as a plus iota b. Now, for making this particular complex number, we have two values of x and two values of b. So when to take plus and when to take minus, that will depend on certain condition. On what condition? On the condition that we are going to discuss now. Let me rewrite this properly so that we'll be able to memorize them better. Let's write modulus of z plus x. That's the same. Okay. So we have two values of a and two values of b. Now on this, on what uh, 4, like we have naturally x is z is equals to x plus iota y. So for y being positive, there can be scenarios where y will be positive. Okay, so if y is positive means, go back. If y is positive, then modulus of x squared plus y squared, then that is definitely going to be positive. And so if we look here and observe, so if y is positive, the modulus is also going to assume its positive value. What positive values? Certainly, let me write this positive value. एक- अरे यार, this positive value, the positive value of A and the positive value of B. So we can rewrite the solution as that A will become modulus of Z plus X divided by 2 plus iota to B. Okay. This will be the square root of Z when Y is positive. So any doubts, anyone?
No, sir.
Okay. Don't you have any question that why have I taken only positive sign of both of these square roots? Let me explain why. Because if we go back and look, what was our assumption? What was our assumption here? Was that y is equals to 2ab. Y is equals to 2ab here. So if y, yaar. Playing with me. So it was given that y is equals to 2ab. And if y is positive more than 0, then 2ab will also be more than 0. So if 2ab is 0, if we divide 2 by both sides, so ab is also going to become 0. Sorry, is also going to be greater than 0. What it means that ab is positive. Now the product of those two terms will be positive only if and only if both of them, A and B, are positive. And also when A and B both are negative. Okay. So one thing is that this A, what was A? देखो यहाँ पे. This A has to be positive and B has to be positive simultaneously in the same case. And it may also happen that we can take the negative value of A. Okay, so there is one more solution for modulus of Z that can take place. That negative of A divided by 2 and negative of B. We have taken the negative of B. This can also be the solution. This can also be the square root of complex number when y is positive. And why it is so, I have explained you here. Clear? Any doubts? Is it crystal clear now?
Yes, sir.
So the A is positive when B is positive. The A is negative when B is negative. Now let's discuss the other case. And see, it's depending on the sign of y only, not x. So for y being less than 0, so 2ab will also be less than 0. So ab will also be negative, less than 0. So this can also only happen when a is more than 0 and b is less than 0. Or a is less than 0 and b is more than 0. So means if one is positive, the other one is negative. If one is negative, the other one should be positive. So how we can write the solution now? The A was simply modulus of z minus of x divided by 2. If we are taking its positive value, we have to take the negative value of, sorry, there was plus here, right? There was minus here for the B. Yes, there was minus here for the B. So this is going to be the case. And also it may also happen that when A is negative and B is positive. Now how we can write like combinedly the solution in this format? Plus minus into square root of modulus of z plus x divided by 2 minus iota into modulus of z minus of x divided by 2. This is how we can write it combinedly. Okay. So when there will be plus, so it will take the first manifestation, first equation form. And when it is minus, so this will become minus, this will become positive. It will take second form. And similarly, we can do the same for the earlier part also. So modulus of g here can be written as plus minus of when A is positive, B is positive. अरे यार, small mistakes. When A is positive, B is positive, and when A is negative, B is also negative. ठीक है? Clear? Any doubts? Any
No, sir.
doubts? No doubts. This is complex, so if you have any doubts, there's no problem. And even if you have any silly doubts, please ask, because if you ask a doubt, you will be silly for 2 minutes. If you don't ask any doubt, thinking that you will be silly, then you will remain silly for the entire life. Okay. So I want you to observe what I have written. Starting from the first slide, we have assumed a complex number z is equals to x plus iota y, and then we have assumed the square root of z is as another complex number a plus iota. Then we have then we solved brought the square root to the right hand side, then solved for the equality for real parts and imaginary parts differently, then made a algebraic identity using which we find it out all the value of a and b, which were different. So then we utilize the given information that y is equal to 2ab. So if y is going to be positive, of course a and b has to be of the same sign. If A is positive, B has to be positive. If A is negative, B also has to be negative. So accordingly, we have written the square root of the complex number. If Y is negative, then then both of the A and B has to be of opposite signs. Clear? Any doubt, anyone? So let me summarize and write. So if Z is a complex number given in this format, and if we have to find out its square root, so there are two conditions, simple condition. If y is more than 0, then the square root of this will be written like in this format. Plus iota to modulus of g minus x on 2. This is also very easy to remember. When y is negative, minus sign this time. Clear? Any doubts?
Yes.
So please remember this. That is artist. Okay. So, and this is important. This has been asked in a UPSC and D. And please don't go on internet and ask for tricks. This is the most simple and easy method for finding out. What you have to do is simply, if there is any complex number given, first find out its magnitude and simply apply this formula. Simply apply this formula. You will be coming out with solution. This is the condition that you have to remember these. Okay? You have to learn them. So let's see some examples of same. So if this is the complex number that is given, first we need to find out its modulus. What is 5 square is 25 plus 12 square is 144. Sum becomes 169. Answer comes as 13. Positive only because modulus is the length. That's why positive. Clear? Now, y, what is the sign of y here? What is x here? Minus of 5. Y is plus 12 here. If y is positive, so the formula for the square root of z is plus minus square root of 13 minus 13 plus x. What is x? Minus of 5 divided by 2 plus this time because there is plus y. Square root of modulus of g, which is 30 minus of x. What is x? Minus 5. Minus minus plus divided by 2. This becomes 13 minus 5 is 8. So 8 by 2 becomes 4. This becomes 2. Square root of 4 is 2. Plus iota 13 plus 5 becomes 18. And 18 by 2 becomes 9. So this becomes 3. So plus minus 2 plus 3 iota is our answer. Clear any doubt? So this is how easy it is. I've just explained you that how this formula come. Otherwise, in NDA there is no need of explanation. But just for your better understanding, I've explained you. And when in class 11th, if you are going to write your exam, then you have to follow the long method that I have explained to you. Okay, the previous method. But only the difference will be that this time we will be having real x and real y. You don't have to take those alphabets in your calculation. Clear? Any doubts, anyone?
No, sir.
Yeah. So let's move to the next question. Okay, so first of all, y is negative here. And what is the modulus of z? 3 square, that is 9. 4 square, that is 16. This becomes 25. This comes out as 5. So if y is negative, the formula of this will become, we will take plus this side and minus this side. Square root of modulus of g, that is 5, plus of x. What is x? 3 plus 3 divided by 2. Iota modulus of g, 5 minus of x, 3 divided by 2. So this is what? 5 plus 3, 8 divided by 2 becomes 4. 5 minus 3, 2 by 2 becomes 1. So modulus of these z will be plus minus 4, square root of 4 is 2. This is 1 only, 2 minus iota. Okay, this is our answer. Any doubts, anyone? You can also cross check by squaring it. Let's square it. 2 minus iota square will become 4 plus iota square, that is minus 1 minus 4 iota. 4 minus 1 becomes 3 minus 4 iota, which is our question statement. Clear? Any doubts?
No,
This
sir.
is how easily you will be able to find out after learning this formula. There's also, like in this format, you have to write your solution in boards. Not boards, actually, it's asked in 11th class. You will have to follow and write the same exact steps to get full marks. Any doubt?
No, sir.
Okay, then I think we have time. Let's discuss one more concept, which is very interesting. Earlier, the whole concept of imaginary numbers started after solving for this equation, when we had to find out the square root of -1, which was then called iota. Now, this time we are playing with some other dangers, and which are to find out the square root of 1, the cube root of 1. Okay, this particular solution of this equation. So now, as that we are fond of playing with dangers, let's go ahead and solve this equation. So if we go further ahead, x cube minus 1 is an algebraic identity. 1 is considered as 1's cube. So a cube minus b cube becomes x a minus b into a square plus b square plus ab. That is x is equals to 0. Now here we can write whether x minus 1 is becoming 0, or x square plus 1, x square plus x plus 1 can become 0. So if this is becoming 0, one solution of this cubic equation is 1. Now we know there will be different 3 roots. So we have finded out one root. Now let's discuss about the other 2 roots. So if we apply the Sridharacharya formula here, if you remember from the quadratic equation chapter, its formula is minus of b plus minus square root of d, which is b square minus 4ac divided by 2a. Now, what is b here? Can anyone tell me? What is ABC here? Anyone? What is ABC here?
A is x cube. Oh, x square. X square.
What is A here?
No.
A is the
1, sir.
coefficient.
1.
Yes, yes. A is the coefficient of x square. B is the coefficient of x. C is the constant.
Constant.
So, yeah, B is also 1, C is also 1, everything is 1. So minus of 1, 1 minus of 4 divided by 2 into 1. So this becomes minus of 1 plus minus square root of minus root 3. So how we can solve square root of minus 3? Like this. Minus of square root of minus 1 is what? This becomes this only. Square root of minus 1 is what? What is square root of minus 1? I've just told you, just before starting the topic.
1.
पढ़ते नहीं हो.
I forgot, sir.
What we are studying in this chapter? Okay, just tell me what is
Cube
the.
root of unity.
No. Complex numbers.
Okay, complex terms.
So what is the solution of this equation? What is x here? Okay, just tell me what is iota square? Oh my God, you guys are not studying. God bless your NDA score.
One moment, sir.
Go search Google.
No, even if I put answer, Google won't give. I'm just thinking.
Is anyone available? Rishi, Tanish, Guru. Tanish is not there. Guru, Rishi. Hello. I guess they are still sleeping with their classes on. Yes, Rishi. Speak. Sir. Yes. What is square root of minus 1? देखो, you have to study. ठीक है?
Sir, I is equal to root minus 1. So whether root minus 1 is equal to means iota.
Yeah. That is what we have been studying for days now.
Okay, so it's iota.
Yes, definitely it's iota. As a teacher, I'm feeling like, wow, yaar. This is iota, okay? So this becomes iota. So this can be written as 1 minus plus minus root 3 into iota divided by 2. So now these are two values of x. One is minus 1 plus root 3 iota. Let me write in a fresh page. So the one value of x is, the original equation was this, where we were actually finding out the cube roots of 1. So the one value of x is 1, the another value is minus 1 plus root 3 divided by root 3 iota divided by 2, minus 1 root 3 iota divided by 2. Now this is one solution, this is another, this is the another. So these three values, these three roots of 1, these three cube roots of 1 are known as cube roots of unity. Unity is what? 1. Cube root. Okay. Now this particular complex number is referred as omega. And this particular complex number is referred as omega square. If you square this number, this is the answer. If you square this number, this is the answer. And if you multiply both of these two, like my omega into my omega square, so like a plus b into a minus of b. If you consider minus 1 as a and this as b, so a plus b into a minus b, so a square minus of b square, okay, into 2 becomes 4 because we are multiplying both of these. Minus 1 square becomes 1 minus the root 3 square becomes 3 and iota square becomes minus 1, which will neutralize this negative sign. So this becomes 4 by 4, which is simply 1. So from here we can conclude that omega cube is 1. And from here we can also write that that omega into omega square is 1. So if omega into omega square is 1, omega is going to be the inverse of omega square. These are some certain values. And also, if there are like 3 roots of a particular equation, so we may write it like this, that these two are the solution of quadratic equation, which is x square plus x plus 1 is equals to 0 originally, because we have let's go back to the previous page and understand this is the quadratic equation which we were solving. So if this particular quadratic equation is having 2 roots, acha, new page, yeah, so x square plus x plus 2, okay. My laptop is very good, but I sometimes hate it. Okay, no worries, we can write it again. So we were solving this particular because अरे यार रुक जा. We were solving please don't laugh anyone. We were solving this quadratic equation, okay, and we have finded out its roots, which are omega and omega square, which are omega and omega square. X square plus x plus 1 is equals to 0. It has 2 roots, 1 plus root 3 divided iota into 2, 1 minus root 3 iota divided by 2. This is referred as omega, this is referred as omega square. We know any roots of any equation satisfy the equation, so let's put omega plus omega square plus omega plus 1 is equals to 0. So this is a very important identity which is used multiple times when we will solve questions. So from here we can say that omega square's value is minus 1 to minus 1 minus omega, okay. So using this same equation, we are going to solve load many of questions, and also uh, from these observations that omega cube is 1 and omega is equals to 1 upon omega square. And also you have to remember what is omega and what is omega square. Clear? Any doubts anyone? What we have just found it out?
Yes, sir.
Yeah. So it's time for today's class to end. We'll discuss the properties in next class. Or should I cover it? No, I will end the class. Okay. Do you have any other doubts?
No, sir. First, let me revise the